GCD of M and N. All right, so we're going to write GCD, which means greatest common divisor. You're given two numbers, for instance, 270 and 250. What is their greatest common divisor? And in this case, the answer happens to be 10. There's one way to do it would be to loop through all the numbers up to 250. And if that number is prime and it divides both of these, then it's got to be part of the GCD, something like that. But that's way too slow. And Euclid figured out a better way. Who is Euclid? You should know who Euclid was. This is Euclid. Look just like that. But Euclid lived, around 400 BC, so 2,500 years ago, give or take. So it's been known for a very long time a better way to solve this problem. And the way to solve this problem is as such, according to Euclid's algorithm, which says that the greatest common divisor of x and y is exactly the same as the greatest common divisor of y and x mod y, the remainder when you divide x by y. It's a tremendous insight because it very rapidly finds GCDs. We won't prove this to you. You should look it up on your own time for proof. But let's watch it in action. GCD of 270, 250 is the GCD of 250 and 270 mod 250, which is 20. So when we take mod 250, we have to get a number smaller than 250. So that's what guarantees that this actually converges. The numbers do get smaller. They have to, but they tend to get much smaller very quickly. Because the second pass would be, here's our new x and our new y. That's the same as the GCD of 20 and 250 mod 20, which is 10, which is the same as the GCD of 10 and 20 mod 10, which is 0. Well, the GCD of 10 and 0 makes no sense. But the deal is, when y gets to be 0, x is your answer. And so we see that we found the answer extremely quickly. Okay, so what's cool about this problem is, although it sounds complicated, it's actually really simple, and it's going to go really fast. Let's go do it in code. Here we go. So to begin with, here's our GCD, and if we run it, we realize our testing is not set up right. We have to turn off has consecutive digits, turn on GCD. We could look at our GCD cases. I don't think they're going to tell us too much interesting information, to tell you the truth. I think we all understand the problem at this point. So we go here, let's put a comment. I took this straight from the write-up. GCD of xy is GCD of y and x mod y. Excellent, so let's do it. So what we have to do is we have to keep applying this rule until y is 0. So long as y is not 0, what we're going to do is we would say x equals y and y equals x mod y. And when we're done, y is 0 and x is the answer. This looks great, but it's not going to work. If we run it, it didn't work because the GCD of it didn't work. Okay. And the problem is that we need here, when we set x equal to y, we've just changed x. And this x here should be the old value of x. We need to do both of these assignments simultaneously. So here's something you could do, okay? You could do like the old x is x, and then we put the old x here. And that actually works. Okay, so that was one way. Some people like to say something like temp. I don't know, I might like old x. But there's actually another cool, clever way to do this. And it's as such. Let's go back out. We wanted to do both of these assignments simultaneously. And Python does that. It has a technique to do what's called parallel, or if you would, simultaneous assignment. I can set x and y, let's put in parentheses, I prefer it that way. Actually, it's not. X and y equal to y and x mod y. And this line here is the same as these two lines. Except it's not, because it happens in parallel. Everything on the right is computed before anything on the left is assigned. So it's actually like using the old value of x here before assigning the new value of x here. And that's critical. That's what allows you to do this one-line assignment. And as you can see, this still works. The reason I didn't put the parentheses in is because we're not allowed to use lists or tuples in this week. And indeed, if I did this, the linter actually allowed it, pardon me. But in general, this week you can't use lists or tuples, except you can do parallel assignment like this, which is acceptable. With that, this is a candidate solution for GCD. And if you actually preferred, you could also have done it this way, as we said. Old x is x is y is old x mod y. And as you can see, that also still works. I would say this is probably the more common solution.